Welcome to FM Insights with Dave Colucci. Today we have Patrick Ramke with Dr. Wally Kowalski, and they're joining me to talk about UAV lighting, and which does a lot for our indoor air quality. So I'll have Patrick, if you would, first just kind of give me a quick update and background of who you work for and your role and position in that company.
All right, sounds good. Thanks for the introduction. My name is Patrick Ramke. I'm a business development manager for Sanuvox Technologies. I have been in the IAQ, indoor air quality, for those who don't know, industry for approximately 6 years. I've been with a couple other companies, but I've really found my place here. We've definitely got a great team, one of which who is on the screen here with me as well, Dr. Kowalski.
Hi, I'm Dr. Vladislav Kowalski. I'm the chief scientist with Sanuvox. I've been here for almost 2 years, and I have worked throughout the industry on primarily on ultraviolet air disinfection and surface disinfection. I'm associated with IUVA, ASTM, ASHRAE, and some other organizations in which we develop standards. And I'd like to show you today how we design and operate UV air disinfection systems. Let me go ahead and share my screen.
Okay.
Let's see. All right. You should be able to see this.
Yeah, we do.
All good.
Okay. Yes, as I said, I'm with Sanuvox up here in Montreal. And I am an expert on ultraviolet light air disinfection as well as surface disinfection. We're going to cover some topics here today briefly: the benefits of UV history. We're going to look at various pathogens. We're going to look at the difference between air and surface disinfection, the different types of air disinfection systems, equipment disinfection, and we're going to touch on chemical disinfectants and combined UV infiltration. Okay. The benefits of UV applications. Here, these are benefits for hospitals, but they apply equally well for commercial buildings, schools, or residential applications. UV can help reduce infection transmission and reduce the likelihood of cross-contamination. It can reduce your liability. This is of some value to healthcare. Reduce hospital stays and opens up bed space for new patients. Now, UV can improve indoor air quality both by reducing pathogens, airborne pathogens, and by controlling VOCs. UV can be used to reduce energy costs, especially in cooling coil applications. It's easy to maintain, and it is safe and affordable. The history of UV air and surface disinfection goes back almost 100 years. The first use of UV to disinfect air is credited to Regard in 1925 in France. The first overhead UV systems were developed about 1936 by Dr. Wells. 1939, an induct system was found to remove 99% of bacteria. In 1940, it was first applied to AC or air conditioning systems, and in 1942 and 47, it was found to reduce respiratory infections and hospital infections significantly. In 1955, it was demonstrated to halt a varicella virus epidemic. By 1957, it was demonstrably proven that UV was effective for controlling tuberculosis. In 1961, a test showed it reduced an influenza outbreak by 89%. And another TB test showed, once again, a significant reduction in TB transmissions. 1997, another TB test showed a staph conversion rate reduced by 60%. And 2007, overhead UV was shown to reduce SSIs in operating rooms after a very long-term study. In 2023, that's this year, ASHRAE issued their famous 241P document recommending certain levels of outside air exchange in buildings.
So tell me a little bit, UVC, I guess, or sort of UV and UVC, the difference there a little bit, and then also from IAQ products on the market. What's the if you can go into that real quick before we jump into something else, because I'm sure a lot of people out there are kind of
Sure.
like, hey, we know what ultraviolet light, we've heard about it, we've seen it for a little while, didn't realize it's been around since, what was it, 1928, so it's been a quite some time on the market. But
Sure.
it really became public here, especially when COVID and maybe a little bit before that. I know I had something back in, probably the late 90s that would help me clean my phone. I would stick my phone in this little box and it would, get rid of stuff on it. And so that's what most people are been introduced to, or clean your toothbrush head or something like that. So if you can give me a little bit of background on that.
Sure. Well, UV science actually goes back to the late 1800s. It's been used to disinfect water for well over 100 years. It was very effective from the beginning. And again, in air disinfection, when they first began applying it, they instantly saw the effectiveness of UV. It can be very effective. And modern UV systems, modern applications of UV are also highly effective. For air disinfection, we're typically looking at 99.9% reductions, verified and certified by EPA testing. For surface disinfection, we rarely see less than 90%, typically 99% surface reduction. Surface reduction systems, if well designed and properly applied, can greatly reduce surface disinfection. And this includes equipment, hospital equipment, cell phones, or anything, even respirators. So let me step forward here. We were talking about ASHRAE 241. 241 specifies minimum airflow requirements, I should say recommendations, for general buildings, commercial buildings. It also allows equivalent airflows to be achieved in place of actual forced airflow, which is very beneficial because ultraviolet light systems can provide equivalent air changes. In fact, they can provide many equivalent air changes. There are no changes to healthcare requirements from ASHRAE 241. We know that we can take performance test results for any air disinfection system and create an equivalent air change rate, or EAC value. This can be used in economic evaluations where we can look at the cost per equivalent air change, or dollars per EAC, the performance in terms of watts per EAC, and we can also evaluate quantitative risk assessment or risk reduction. Yes, go ahead.
I was going to ask, when you put these into the HVAC system, is there a CFM, a specified CFM that you're supposed to use to blow by that ultraviolet light, or does it matter what, if we're blowing 2 cubic inches or 1 cubic inch, or is it?
Yes.
Okay.
Yes, the all air disinfection systems placed in ductwork must be sized precisely. They must be engineered for the particular airflow as well as for the duct size. So these factors are a matter of engineering. All the information is available. Systems can be sized to deliver particular level of performance. And the minimum level of performance is typically 99.9% for air disinfection.
Okay, great.
And air disinfection systems can take out viruses at high rates. This is a chart of doses, or D90 values, and a large number of viruses. You can see here we've got the SARS coronavirus in the lower right-hand corner. It is, in fact, the weakest of all the viruses and is literally off the charts. It actually sits below the 1 microwatt millijoule line. But most other microbes are easily covered with 20 to 40 millijoules per square centimeter. And for adenovirus, which is really largely a water problem, you might need higher levels, but we don't see that in air very often. And that's for viruses. And we also have one for bacteria. And again, the bacteria, the high-end bacteria, are even weaker than the viruses. And you can see here, surprisingly, nature has bunched up all the bacteria below 10 millijoules per square centimeter, which is a relatively low dose, easily achievable by any system. The bacteria which are more resistant are mostly spores, like anthrax, Clostridium difficile, and Bacillus cereus. They can be easily removed by filters, So it's not really a problem if our system delivers 10 to 20 millijoules per square centimeter. The microbes that are larger, physically larger than those, can be removed by filters very easily. Now, there are two applications, airborne and surface-borne, but these are interrelated problems. In any building, large airborne microbes will eventually settle downwards, depending on their physical size. They will settle on horizontal surfaces, but very small viruses may remain airborne indefinitely. They may never actually settle before they die of old age. Surface-borne microbes, or we call these fomites, can be aerosolized by human activity and air currents. Any microbe that is settled on a surface may likely be re-aerosolized through activity. Now, UV has been shown to reduce levels of airborne contamination, and it has also been shown in two relatively recent studies that it reduces levels of surface contamination. It literally cleans your building over time. Your building surfaces will become progressively cleaner over time as UV disinfects the air. Now, microbes can persist for many months in your building. Some microbes may only last a few days or a day or two or even hours, but certain microbes, for example, C. diff spores, can last over 3 months, almost 100 days. There are a number of microbes that can survive even longer than that on indoor environmental surfaces. When the conditions are right, if the air temperature is warm, there's moderate humidity, and there's no sunlight, microbes can last a very long time indoors. Now, air cleaning systems. We can identify 4 distinct types of air cleaning systems. One is in-duct UV air cleaning, and the next is portable UV systems. There is really no difference between portable UV and in-duct. But then we have upper room UV systems, which are unique. And we also have, recently we've seen whole room UV systems running on far UV lamps. The latter two are extremely similar, and we can lump them together. So there's really only 2 types. There's in-room, or there's in-duct, and then there is in-room systems. Now, in-duct systems are highly effective. As I mentioned, we never get less than about 99.9% reduction, simple to install, cost-effective, and there are various standards for verifying the performance. And in-duct systems always combine very well and efficiently with filters such as a MERV 13. Okay. Now, when we combine filters in UV, the filter takes out the larger microbes, whereas UV tends to destroy the smaller microbes, smaller bacteria and smaller viruses, whereas the filter can remove large spores, fungal spores, and bacterial spores. Therefore, ASHRAE has acknowledged this fact and has recommended a MERV 13 be combined with any UV system.
What size pleat is that? Is that, like a 3-inch, 1-inch? Do you know on that MERV 13? Are they requiring a specified?
MERV 13 filters, I think they're about 1 inch thick typically,
okay. Yeah.
And the pleats. Well, I don't know how many pleats, but there's probably a couple dozen across an 18-inch width of the typical filter.
So pretty much a standard 1-inch pleat would work depending on the size of your duct size, right? So you can put in a 20 by 20 or whatever.
They're pretty standard, and they're widely available.
Yeah.
Standalone units are like in-duct units, except they're portable. They can be equipped with MERV filters. Many of them already have HEPA filters. They have their own fans, and they can be applied for spot treatment in individual rooms. It's a little bit of an expensive option compared to in-duct, and yet if you can't put an in-duct system in, it's probably the next best alternative. Now we have upper room UV systems, which have been tried and tested for many decades. They're very effective against any airborne pathogen. There's an extensive amount of research demonstrating their performance. They're low power consumption, easy to install. However, the performance can be highly dependent on room air mixing conditions. It's something we don't know a lot about. Surface disinfection can be accomplished with typical tower systems. These surface disinfection systems typically will disinfect up to 99.99% of surface-borne contaminants, depending on the length of time you apply them for. They are only applied after surfaces are cleaned with chemical disinfectants. This is standard in hospitals. We can't use UV until chemical cleaning agents have been used first, because they wipe away possible stains and visible soilage, whereas UV only operates on visibly clean surfaces that have already been wiped. In-room UV air disinfection systems such as FAR UV are coming into becoming popular. They have been installed in various locations. What we're looking here in the photo here is actually what we call a barrier system, and these are very old, except they've been redesigned with FAR UV systems so that people can walk with them without any hazards. We don't know what the regulatory agencies are saying yet. They don't seem to know themselves what to think yet about FAR UV. But we're hoping that in the future we'll be allowed to use FAR UV in human-occupied spaces. Other applications include hospital overhead systems, disinfection of handheld equipment, even doorknob disinfectors with LEDs may be very practical. Hand wands are not recommended. There's too much trouble with those, too much hazard, and they don't seem to be very effective. And that's my presentation. I'll be glad to take any additional questions.
All right. So I know you went over quite a lot of information there that some of our viewers and listeners probably over their heads just as much as it went over mine. But tell me a little bit, what is some of the greatest benefits that you see from the UVC today? Because I notice, you're saying a lot of it takes out 99% here and there. And I see that, you said also that putting it in the HVAC system is better than just sitting it outside. So, what are some of the benefits that you see, the biggest benefits? And then also, is it just in hospitals, or is it, clinics, or actually do you see any of this in like office space so that you can avoid, building sickness?
Well, certainly hospitals have always been using UV systems in various applications. But what we're concerned about today is coronavirus and pandemics and local epidemics. This is what we're focusing on. This is what the general focus is moving toward, to controlling airborne transmission of disease in indoor environments. And certainly more than at least 99% of transmissions are occurring indoors. It's been well demonstrated. Outdoors, you have the sun, the air, the wind, the oxygen. You're not going to get any transmissions outdoors. It's just not very likely. Indoors is what we need to focus on. We need to clean the indoor air. We can clean it through ductwork by cleaning all the building air through ductwork. If we can't put it in a central air handling unit, we may resort to portable units, but a somewhat more economic alternative might be upper room units. Upper room units are relatively cost effective, and they've been proven to be highly effective, although they're subject to variable conditions in rooms. However, you can put upper room units in any room that is occupied, and it will be certified safe. They will measure the UV levels and make sure it's safe for human occupancy. And the same thing goes for FAR UV systems that are available now. They can be put in any occupied room, but they must be certified safe, and levels must be below NIOSH limits. We believe these would be very effective in meeting the requirements of ASHRAE 241. Now, ASHRAE 241 is recommending something like 6 air changes per hour. Most buildings do not have that presently. They're lucky if they have 1 or 2 air changes per hour. Now, many people think they might be retrofitting their air handling units to increase the airflow from 1 or 2 ACH, air changes per hour, to 6 air changes per hour. They may quickly discover that that's a very expensive option. And if they look at the economics of UV systems, they might find that they are easily 10, maybe 20 times more cost effective. You will get the same kill rates, you will get the same processed amount of airflow with UV at a much, much lower cost than blowing in outdoor air. And if you did blow in outdoor air, you'd have problems with heating and cooling in the summer and winter. It's not a very economic alternative, and it's the opposite of decarbonization, which I think we are all interested in today. We want to reduce energy consumption, and UV offers one possibility of reducing energy consumption. Instead of putting 6 air changes per hour with big fans and ductwork, we can put in, for example, upper room units in all the rooms and not boost the airflow at all. And we will still get high performance. Therefore, we can both decarbonize a building and clean the air at the same time. It's not impossible. It's just a matter of engineering the right systems to do that.
I was going to say, Patrick, jump in anytime because I've been spending a lot of time with Dr. Kowalski.
Patrick may have something to say about it.
Yeah, that's right. I take the more, the Socratic approach. I'm the sales guy. I'm out in the field all the time. So it has expanded from healthcare. It is now used. There's the versatility of UVC is amazing. It's been used in different applications across the board. Another big one is food processing, food packaging. There's been a lot of outbreaks of diseases like E. coli, listeria, things like that. And this has been used in a lot of food processing plants to make sure that their food is protected all the way up to the packaging point. And even people who are selling the packaging to these particular plants are blasting their packaging with UVC just to make sure that there is no biocontaminants on it before the food is packaged closed. Another big industry that has taken a lot of interest in UVC is the cannabis industry. You guys get that pretty big in the Las Vegas area, but a lot of states are now regulating testing for the cannabis before it can be sold in the open market because people with compromised immune systems are going into these recreational stores and purchasing cannabis prior to it actually being tested, and then they are dying from inhaling dangerous molds and bacteria that jeopardize their breathing and then end up killing them. Right. So states like California have severely regulated the amount of biocontaminants that actually can appear within the cannabis itself. Biggest one, Aspergillus niger. Everybody knows this one, black mold. If you've seen it sitting around, standing water that's been sitting around for a while, it pops up. Yeah. It is extremely dangerous for people who have compromised immune systems. And this is something that is pretty much always around in the grow facilities just because they generally operate between 50 and 70% humidity at any given time. And that's just the ideal environment for bacterial mold growth. And then just kind of name drop a little bit. I did work with some of the casinos on the Strip during COVID. So if anybody's looking for the safest casinos on the Strip, Venetian Palazzo, I didn't say that, but they took a very big interest in UVC during the pandemic and outfitted their casinos with a lot of it to make sure that their guests would be able to come in and feel safe within that environment during those times.
Wow.
I mean, the applications are limitless, and those just kind of touched on some of the more major industries that have really come to accept UVC as a standard within that particular field.
Okay. So I've heard a little bit about it and have done a little bit of research on it. And so kind of explain a little bit about the lamps and the lifespan of the lamp and best place maybe to put the lamp in, those types of things, so that we understand, you just don't jump up in a ceiling somewhere and throw it in. It's got to be in a specific area, and then being able to access that, regularly. I don't know if you want to say regularly, but be able to access it so when the lamps are time to change out. So if you can talk about that a little bit.
Okay, we use basically two types of lamps. One is the low pressure UVC lamp. It emits at 254 nanometers. Also, we sometimes use medium pressure UVC lamps that emit at a more broad band, but they include 254 nanometers. And also medium pressure lamps produce a little ozone, whereas the low pressure lamps produce no ozone at all. And the far UV lamps that are in use have a tendency to produce ozone. They emit about 230 or 222 nanometers. They produce some ozone, but there are ways of controlling the ozone. There are systems that can reduce the ozone levels. There are also LEDs, which can be designed to emit at virtually any wavelength. Unfortunately, the power levels are so low that they're not suitable for large-scale applications. They're suitable for small niche applications. Doorknob disinfectors are probably a good example. I designed an LED system for the space station, which is very compact. It was suitable for that application. But until the LED prices come down and the power output goes up, we can't see them being used in any large scale applications.
Gotcha.
I think that covers it. Those are the only kind of lamps we really look at.
Yeah. So, and then the lifespan of those lamps, how long do they
Oh,
last?
yeah. UVC lamps, medium pressure and low pressure lamps, will typically last about 10,000 hours, which means a once a year change out.
Okay.
The LEDs, I can't tell you anything about, but the far UV lamps are rated for 4,000 hours, which means you might have to change it twice a year.
Okay. And then a placement within your HVAC, is there a specific spot that you put those? Is there?
Ideally, the lamp would go in a long stretch of ductwork, because the longer the ductwork, the more exposure time you get.
Okay.
Often lamps are placed in air handling units because they often are interested in disinfecting the cooling coils, getting rid of odors and mold growth in the drain pans. But air handling units are often so compact that there's not enough space to do any significant air disinfection. So typically a narrow space might be a foot or 18 inches, and it's not quite enough to do a good job on the air, but it's good enough to do a great job on the coils. So we often recommend, if they already have a cooling coil system, they just add some additional lamps to some stretch of duct before or after the coils, and that will give them a great deal of air disinfection capacity.
Great.
These are things that we definitely analyze when we, talk to each individual interested party.
Mm-hmm.
We will look into their systems and see, because UVC has the ability to degrade softer materials. We don't deny that. And so we work with that and make sure that it's not going to do any damage to the system. So that's why we're very particular on where we choose where to place the UV. And each situation is individual. Everybody's got a different solution. So one solid answer is not really a copy and paste. So we kind of we have to see each one and size it accordingly based off of something like that.
Yeah, I get it. Sometimes those units are set somewhere where it's just hard to access them, and especially if you're going in after a VAV box and getting past the filtration system or before the coil or so forth, it could be in the most weirdest spot, and trying to get up there to take care of that can be a pain. I've wrenched my back trying to get up into these little areas and pull a panel off, and it's crazy. Some people just don't pay attention where they put them, and because they're just looking at, oh, this looks great. And then a drywaller comes by, or a framer, and he puts a wall up right next to it. And now you've got 2 inches to access it. But yeah, I get it. Yeah. So you have to look at each application and see which works best for you. Yeah. Great.
Yeah, absolutely. Yeah.
Every application is almost a unique engineered system. Unless we're just putting in portable units or upper room units, in general, we have to engineer the system uniquely for that building.
Yeah.
And there's one issue I forgot to really cover, and that is VOCs and odors.
Yeah.
UV can take out a large number of VOCs and odors. We've been discovering that again and again. It can be chemically reactive with certain VOCs. UVC lamps, low pressure lamps that produce no ozone, are capable of inactivating a wide variety of chemical compounds. But medium pressure lamps or vacuum UV lamps produce ozone, and the ozone has a superior effect. Greatly reduces odors and VOCs, but you can't have residual ozone. So you have to size the system exactly such that any ozone level produced is consumed by available VOCs and odors. If you have a lot of people or foods in a room, you're continuously producing VOCs, and any ozone that's produced by, say, a medium pressure lamp will be consumed in time, and you won't measure any actual ozone. So these types of systems to reduce VOCs and ozone also have to be engineered exactly and precisely for any individual application. But the option exists for removing all kinds of VOCs, especially when we use either far UV, medium pressure lamps, which produce ozone.
Okay.
Okay.
So is this different? So tell me a little bit about the UV lighting and what it actually does to the air. Because I've heard of things where creating the ozone, they're going in and they're taking the hydrogen molecule and breaking it out, and that goes out and actually turns into like a hydrogen peroxide almost, and attacks.
That's correct.
Okay.
That's correct. If you have a medium pressure lamp or a far UV lamp and it's emitting frequencies or wavelengths that generate ozone, then ozone gets generated. The ozone often reacts with water molecules and oxygen in the air to form hydroxyl radicals. Hydroxyl radicals are very good scavengers of other chemicals. They will destroy just about anything that's in the air, and they are relatively short-lived. So hydroxyl radicals are not so bad because they're short-lived. We often don't even record. We often can't even record them in the air, but we know they're being produced because ozone is being consumed, especially in highly humid air.
Gotcha.
But, to address if people have any fears about it, this is one of the same things, too, that we address for each individual case. Mm-hmm. We assess it, see if it's something that would be applicable in that particular situation, and then size it accordingly to make sure that it is a safe amount that would be going in, into that particular ductwork.
Right.
Otherwise, we'd use it for areas where people would just not be occupied whatsoever, for like garbage rooms, which is phenomenal. I mean, we do have sensors, infrared sensors as well, interlock door switches to make sure systems shut off if people come into the room, or if it's just essentially scrubbing the air before it's being ventilated out into the outside air for like cannabis facilities who will receive daily fines from the city if the neighbors are constantly smelling the cannabis. So they have to do something about the air that's being ventilated out, in which case the UVV option is phenomenal for something like that. Right. And that really rids them of the problem, and it doesn't really affect them negatively in any way.
Yeah. Good. Patrick, why don't you tell me a little bit what makes Sonovox stand out more than any other company, or more than other companies? What's your biggest selling point, I guess?
I can feel that first. I've didn't get a chance to explain, but I have worked for a couple other UVC companies, and they all have great merits to their products. What I think really makes us stand out compared to some of the competitors is just our variety of products that we have out there to attack different situations. One of the biggest ones that was always extremely hard to outfit were mini splits. Ductless mini splits have always been very difficult. And so a great solution for something like that would be a standalone unit. And a lot of competing companies do not have adequate standalone units that will be able to get the job done. We not only have a standalone unit, we have multiple different versions of standalone units to meet everyone's different needs. So you're able to tailor it, and it reaches a larger section of people that you would never have been able to talk to in the past. Yeah. Not to mention surface disinfection, as well as just taking more care in the science and paying attention to the actual proper sizing, where there are some companies out there that will just slap on lamps and say you're good to go. Yeah. And not really size it up. And honestly, that takes away from the validity of the value of the science of UVC. Mm-hmm. And it really kind of turns people away. So our focus, especially with bringing in Dr. Kowalski here, is making sure that we're doing it right the first time, and making sure we're validating that science every time we go into each different facility and we're outfitting people's buildings with UV to make sure that we get the job done for whatever task they have asked us to come in and remediate for them.
So, okay, great. So can you tell me, we've kind of got a couple of questions here that I've written down. So what is ASHRAE's stance on UVC so far? I know you talked a little bit about it, but are they fully backing UVC? Are they saying, hey, this is the best way to go? Or are they, kind of just recommending like some other new product out there that, okay, yeah, it passes ASHRAE standards? And can you kind of give me a little more information on that side of it?
Sure. I'm in ASHRAE. I'm on the ASHRAE Service Disinfection Standard Committee. They also have a standard for testing UV systems. They have a model room standard in which any kind of air disinfection system can be tested and certified for its performance. ASHRAE's been fully supportive of testing standards for UV. And it's clear from ASHRAE 241 that they accept UV, and they accept it in the sense that if it can produce an equivalent air change rate, it can be used in place of outside air. It is implicit in the ASHRAE standard, and it opens the door to a wide variety of applications. Any UV air disinfection system can be rated and tested and measured in terms of its equivalent air changes. This is very easy for in-duct systems because the equivalent air change is simply the airflow rates times the efficiency. If it's approximately 100% efficient, that is 99.9%, and it's got 2 ACH, then you have approximately 2 ACH of equivalent air change. It's a little more complicated for upper room systems. They've been demonstrated to produce high equivalent air change rates, 6 to 10 or more. But it remains to be proven based on an actual certified performance test what EAC they can produce. And there are methods for doing this. We can certainly match test data to the outside air performance curve and determine how many EACs we're getting. Nobody has actually done this yet, but they will be doing it very soon when they start to look at the economics of retrofitting buildings. Do they want to put in a new fan with 4 ACH? Or do they want to put in upper room units? Or do they just want to put lamps in their ductwork?
Right.
All of this can be evaluated down to basic economics, and there will be a clear choice every time.
Anything to add to that, Patrick?
No, I think he covered that pretty well.
Okay, good.
It's kind of hard to follow him, unfortunately.
Yeah, right. Good.
I could mention that we've worked out all the equations and algorithms for determining the equivalent air change rates for upper room systems, far UV systems, and of course for in-duct and portable units.
Yeah.
We haven't published it yet, but it'll be published very soon, and everybody will have the tools they need to convert their UV systems into EACs and to start doing the economics or the performance evaluations.
Cool. So tell me a little bit. You talked about your portable units. So what would be, the smallest size that, and I'm talking about square footage of a room that you'd put a portable in? Do I want to stick one in my office if I can't afford one for the whole university or whatever? Or, maybe I want to stick one in my classroom, and is there a specific size for that? I know you said there was multiple different ones. So if you can kind of talk on that point a little bit, I'd appreciate that.
Okay, we are very confident in the CDC's estimate for upper room units. They have proposed 30 watts total UV electrical power draw for a 200 square foot area. We find that is more than adequate, and all the test data throughout history suggests that works very well as long as your room mixing is good. Therefore, as a minimum, we would accept CDC's estimate on wattage per square footage for upper room units and also for far UV, which is very similar in operation and in power requirements. For in-duct systems, of course, ASHRAE dictates how much air is delivered to the room, whether it's for personnel comfort and breathing or for heating and cooling. And therefore, whatever is required to be the airflow rates, we simply size the UV systems for the existing airflow rates or the predicted airflow rate. So it's pretty cut and dry in most cases.
So if I tell you, I've got a 10,000 square foot classroom, you'd be able to say, okay, this unit fits your space. It's going to cover everything, and we'd be good to go from there.
Yeah, that'd be about 100 watts total, I think.
And then, multiple units maybe sometimes would work, or do you think that you just have the one unit, it's going to work and it's going to be good?
Well, we're thinking that we need UV in the duct because every building has a fan in the duct, almost every building. Yeah. Therefore, we might as well put UV lamps in the duct and get the 1 ACH or 2 ACH of completely clean, disinfected air. The rest has to be made up room to room, that is occupied room to occupied room with UV units, either portable units, upper room units, or far UV units. Now, they'd have to be individually sized for each room, but as I mentioned, the CDC guideline is very good for upper room, even far UV units. Portable units goes back to ASHRAE, but the CDC guideline is sufficient. So if you know how much square footage you have, it's a simple matter to size the unit for those areas. And as far as the other rooms, the hallways, the closets, the lobbies, well, all the clean air that's being disinfected in the individual rooms is being exfiltrated out of those rooms to the hallways, the lobbies, and anywhere else that you need it in the building. So we focus on treating the occupied rooms and let the spillover clean the rest of the building. Okay. I think in principle that should work very well.
Yeah.
I did come across a very unique situation during COVID. We had a lot of requests for UVC, obviously, because everybody was looking for a solution. But one of the most interesting and most targeted groups were schools. Schools were definitely the largest one to want to open. And a lot of the complaints that I got were that a lot of the maintenance guys would say, I don't want to have to run our systems 24 hours a day to be able to purify the air before students come in. It just racks up my bills. So I'm looking for something a little bit more economical. And that's where the standalone units really came into play too, because they were able to just plug it in and shut it off when the day was done, or if they wanted to move it to another classroom, they could. And I believe Clark County did something similar to that with the school district as well. And I'm pretty sure they're looking into something again in regard to adding some more indoor air quality products like that. But we can tailor it to, like I said, each one of those different person's needs. So if you got a school who doesn't want to run their systems 24 hours a day and rack up the energy bills, this is a nice alternative solution where we can just run our own lower powered fans to get the job done and still purify the room very well. And then we also have even lower profile, like our S100, which basically looks like a little ceiling panel. And it has a very low profile fan with the UV light and just continually runs 24 hours a day, very low profile, very low energy draw, and they can run that all the time and not have to worry about racking up energy bills.
Yeah. So I was noticing in your presentation, I saw some of the upper room light fixtures that you'd put up in there. And if I was to be just a normal guy looking at that, I think, all I have to do is buy this lamp and throw it in my light fixture and I'm good to go. But can you explain a little bit more about that, just so that people don't think that?
Okay. Upper room systems can only create a UV kill zone in the upper room. That kill zone cannot be in the lower room because it would probably exceed NIOSH threshold limit values for UV. Now, those are set very strictly by NIOSH, by OSHA, ACGIH, and others. Therefore, anything below the upper 1/5 of the room has to be free of hazardous UV. The intense UV radiation can only exist in the upper zone. And therefore, these units that they use typically have grills on the front. They try to force the light to be parallel so that you get parallel beams of light going across the room and not straying down into the occupied zone. That's basically what the grills are for. They try to concentrate all UV in the upper zone. And that's where the UV is operating to clean the air.
Gotcha. Good. Well, good. We've been joined here by Lance now from D23. And Lance, we've been talking for probably a good 15, 20 minutes and kind of discussing things. What's your part in all of this?
So I'm a manufacturer's representative. I represent Sanuvox and a few other products. And when it comes to a lot of this technology, there's a lot of noise that goes on. We have a lot of bad actors in the industry to the point that you could go to Amazon.com and buy a hand wand with a UV light, so they say, so you can disinfect your hotel room,
right?
Which is wrong on all kinds of levels in this information. And that's the biggest thing that we see out there was that all this noise, especially during COVID, it was very hard for us to qualify our information to get it out in front of the clients. You talk about the schools. I am an owner's consultant. I'm an engineer's consultant. And so I would have to educate them that putting a UV light in a traditional air handling unit or package rooftop unit basically disinfects the coil.
Right.
Its job is to attack, mold and mildew on the face of the coil, but people would do that. Bad other representatives in our area would go out and promote that. So we have UV in our units and you should do this technology. And I do apologize for missing the earlier portion of the meeting, but what I liked about this particular product was honesty in the data, background in the data, backed by ASHRAE. And then when we look at jobs, we look at a dosage. So in that, it's a matter of basically the amount of time and energy that we put across that molecule that we're trying to get. And we look at it as engineers and scientists when we're doing this. So everything is dependent upon your application. As being with Roseman University, you're going to have different applications than a school district would.
Yeah.
Same thing is that we can apply this technology towards trash rooms and odor remediation. That molecule performs differently. Years ago, I was involved in writing the City of Las Vegas's ordinance for marijuana.
Mm-hmm.
And we were going after it empirically with subjective data. Basically, we put a nasal ranger was the product on your nose, and you go around and sniff it.
Mm-hmm.
And the problem is you become nose blind.
Right.
And we said, we have data. And it's a room full of scientists. I'm like,
Yeah.
why are we doing this? We're a room full of scientists. We can apply numbers, and we had
Yeah.
an industrial hygienist at the time, and we developed this standard. That's why when I promote a product towards a specific application, that I go down that rabbit hole before I decide I'm going to state it qualifies for a specific application.
Mm-hmm.
And I think the technology is backed by that, and so is this manufacturer.
Yeah.
When a lot of the early actors came out years ago, we have ionization technology that was promoted. I actually reached out to the CDC and asked for their guidance. I had a friend of a friend and said, "Hey, what do you got? We're seeing a lot of this information. How can you help me with that?" And that's the biggest thing is, and I'm not, to our guest speakers is the question is how does a client today, how does a facility manager, an owner sort through all of this noise that is popular, is an easy spin? I was talking to you.
Yeah.
There's a particular entertainment star right now promoting technology that is false, and it's preying on people's emotions as opposed to the science behind the technology and how it's applied.
Right.
To you,
Yeah,
how do you sort through all that?
Yeah.
Maybe I can answer that briefly. I would say we really have to listen to the major agencies such as ASHRAE, IUVA, and even ASTM, and possibly even EPA and FDA. What they have to say about UV applications is important. And what they have to say about these other technologies, ionization, et cetera, is also value. ASHRAE does not favor ionization. I don't think most people in the industry do. It's not terribly effective. Even if it's cheap as heck, it's just not very effective. There are other technologies out there which might be effective. We've heard of hydrogen peroxide systems. They can work in hospitals. They might not be very practical for commercial buildings. The rooms must be unoccupied, and I think there's a residue, and there's certain chemical reactions that can occur, bleaching. So it seems a bit messy. I've seen these systems, and they work very well in hospitals. I don't think they would be appropriate for commercial facilities or classrooms, but maybe they are.
Good. I know we're running up on the 2:00 hour. So for you, Dr. Kowalski, I know you got to head out here. So
I will excuse myself. Thank you for having me on.
Thank you very much. We appreciate
you.
your time and your talent, and your knowledge in this field. So thank you very much.
You're welcome. Bye-bye.
All right. I had a question and I got to remember what it was. But anyway, we can talk a little bit more. So Lance, you were talking a little bit about ionization and a couple other, and the noise out there. And I know that noise gets pretty big sometimes, and probably some of the reasons I backed off of it. But I hear, and again, this is noise, but the new Omicron variant that's coming out. And so, I wonder, because of hype, if this will elevate, people wanting to purchase again the UVs, because I know there was a big deal, and Patrick, you said that there was a couple of casinos that have purchased and put it in so that they can say, hey, we're safe, and they are. I'm sure they are. But a lot of people held off and not, and so do you see a flux in the way society runs with the scare of different, coronavirus scares and that, and all of a sudden everybody wants to buy it, and then pretty soon, they slow down again? And do you see that going on as you hear the news and different things like that?
For me, yes.
Yeah.
That is definitely the case. I mean, I've lived through a few of these scares. We had, in my career, I've been doing this about 25 years, and we started off with anthrax.
Mm-hmm.
It was a big scare. How do we deal with that? Then it was the swine flu early on. And then really it was quiet. We do have a lot of resurgence. The new threat is always around us is the bird flus and variants of the bird flus. Mm-hmm. That's very relevant. The price of eggs went up because of that, decimated our chicken populations. So typically what we see from facility manager directors is they're given a directive, what should we do?
Mhm.
Right. So I previously worked at UNLV.
Yep.
They consulted me and they needed to have an emergency report. Okay. What do we do in case of this emergency?
Right.
And we go through and we do costing and we create a report. At the end of it, the report has a price tag to it. We say, okay, great, here's your report.
Yeah.
Give it to your manager. Manager goes, that's great. That's too much money.
Yeah.
I'll put it on there until such a time that we're either sued.
Yeah.
Or there's a public demand or regulation to handle it.
Mhm.
A lot of people want to do the right thing, but they're bound by capital costs. And I think there was a conversation about how do we promote this as facility managers. If we want this, or a building owner wants to promote this to your client, then okay, let's figure out how we get there. Right? Here's our
Yeah.
cost.
Yeah.
So one way we could do that is, again, there's a lot of noise on how we reduce our outside air. In our particular part of the country, it's so dry that outside air isn't that big a deal. I mean, it's a
Right.
big deal. It's very hot.
Sure. Yeah.
But if you're in territories that are like Louisiana,
Mhm.
Missouri, very hot, very humid, outside air has a huge impact on their energy consumption. And so you, as a empirical scientist, as an engineer, I would want to run some studies to show some evaluations. So if you're a facility owner and you have multiple properties, pick a property,
Mhm.
Make the investment, and see what your return on that investment is in actuality. Otherwise, you're going to get salespeople, good salespeople,
Yeah.
that will come to you with one plan or the other, and you really won't know until you try it.
Yeah.
So if you're a large school district, Clark County,
Yep.
should be able to do that.
Yep.
Buy a building, invest, see what the air quality is. We have the measurements in place. Make it as an experiment, and see what that value is, and publish that value. Roseman may have a building wing. You
Mhm.
could try that on. UNLV could have a building wing that they could try that on, and then model it, and then tweak that data, tweak that performance so that you do get a return on your investment. That way you maintain the goal of protecting your people, either your employees, your clients, whatever. And you are actually paying attention to your bottom line.
Yeah.
That would be my best suggestion. Otherwise, a lot of things are modeling. And I used to do modeling. It was fairly accurate. But there is a little bit of a gamble to it.
Sure.
And being in Vegas,
Yeah.
we
Roll the dice.
try not to do that, right?
Yeah.
And a lot of these
exactly.
facility directors also have been burned by that over the years. We've seen different technologies deployed
Mhm.
only to be removed. One, because either it didn't produce results, or the facility managers or as the maintenance team did not understand the technology.
Yeah.
I've seen that so many times.
Right.
Whatever brand, whatever technology, it's not supported. They don't maintain it.
Yeah.
Bulbs don't get changed. Filters
Right.
don't get changed. So as far as trying to get ahead of a cyclical pattern, we as an industry and as a consumer need to figure out, okay, we see this as a value. We know this is coming down. We know these things are coming down.
Mhm.
How do we get ahead of it?
Yeah.
And it's a proactive judgment call by facility managers that want to promote the technology, or a building owner that wants to promote similar technologies, and a little bit of experiment. Now we have case studies. Every manufacturer has case studies. Reach out to a rep, qualitative rep that you trust.
Yeah.
That's been around a while.
Yeah.
And that they have a reputable factory supporting them, and play with it. I don't want to purport to say, hey, this is going to be knock it out of the park every time.
Sure.
Mine is more walk into it slowly and let's do an assessment.
So Patrick, have you seen where people have actually published their data showing that it's doing what it's supposed to be doing, or is that kind of something that once it's done, people kind of look at the data and they just kind of keep it to themselves? And because if there's something out there where us as FMs could actually look at the data that's published somewhere, and we can say, oh yeah, this is my facility to the T, or it's somewhere close, and we can say, yep, this was work. So I can start seeing the value in it and actually have data that I can report to my uppers to say, hey, here's data that's out on the market, and it shows that, you can save this much money. People are, because sickness is down, and, patients are doing better, and employees are feeling better, and so is there that kind of data out there?
Absolutely. And and that's honestly my best selling tool. As we're just talking about, I'm the guy you shouldn't be trusting out in the field. Don't just take my word for it.
Yeah.
Just use your own scrutiny. Understand what you're learning about and what you're potentially investing money in. Follow the paper trail of evidence. There's just troves of white papers, independent studies that have no money involved in the situation, where they've actually done the independent research and verified that it does work. My favorite one, which Lance just mentioned with the anthrax scare in the early 2000s, the EPA and the Department of Homeland Security were scrambling for solutions if this were to ever become a major issue in the United States. And the one technology they came after was UVC. And so they went to a bunch of specific UVC companies and asked them to put together a solution for that particular situation. And so a lot of them actually have verified tests from the EPA and the Department of Homeland Security verifying the efficacy of the product. Ours was definitely one of them. We were at the top of the list for the greatest output and getting the job done the best. My predecessor that I worked for was close second. They did very well as well, just making sure the output was really there and just analyzing and making sure that you're getting the job done. Because all this data exists out there for you to find.
Yeah.
Don't just take people's word for it and verify it on your own. If even scrutinize some of the tests, like, I had, there's a lab test that verified that this product does work. I mean, there's people that you can just pay money and they'll put together a test and say, yes, it does work. It may work in a certain sense, but they'll cherry pick certain aspects of that study and push that and then hide the rest of the study from you.
Yeah.
If they're only showing you select aspects of that study, ask for the entire study.
Yeah.
I personally am more than happy to hand out the entire study of everything with UVC, which is why I feel so comfortable offering this product.
Right.
Is because I know it works.
Yeah.
I am not a scientific mind by any means.
Yeah.
But all you have to do is be able to read. If you read and just be scrutinizing of the data that you're looking at and analyzing the sources of information, if it all seems that it is all impartial and they have no benefit of producing this information, then this is something you should follow and say, yes, this is actual legitimate information that validates how UVC works or how any other indoor air quality products may work. There are other ones out there. Ionization is the one we've been kind of focusing on in this conversation, but there's PCO, photocatalytic oxidation as well, and it does work to an extent, but there are limitations to the technology, which people kind of like to dance around when they're selling it. Yeah, it does work, but it's based on surface area. The air actually has to hit the surface area for that catalyst to actually take effect and remove all the organic compounds or mold or bacteria out of the air. And a lot of them, actually all of them, are not sized for the exact ductwork because that'll just put way too much stress on a system to be able to do something like that. So they'll just do maybe like a 2 foot by 2 foot square.
Right.
Illuminate it with UVC to activate the catalyst, and it scrubs it, but it's going to require multiple passes before it gets the job done.
Right.
So like I said, it does work, but you really have to kind of break it down and analyze how it works. And just that's finding all the available information from independent sources and coming up with your own independent thought process and conclusions off of each technology.
So there's no one place that you could go to find data. You have to really go out there and kind of search it up and look for it.
Well, you can always reach out to me. I've definitely compiled a lot of that data.
I know I could go to you or Lance, right? Those are my first two. But I mean, for just the average FM that's out there looking for data, he's not going to be able to just type into Google and say UVC data on casinos and come up with some data to say, oh yeah, so and so did it, and this is the square footage of their space and blah blah blah. We're not going to find that.
No, they're going to run into a lot.
Not that specific, unless they conducted their own independent tests, which. When I did work with the Venetian and the Palazzo, the Venetian in Macau actually did an independent study on their own to verify the efficacy and making sure that it was purifying the coils itself as well as the airstream. And I actually brought that in and presented it to that team, and they were like, wow, we didn't even know we had that going on.
Yeah.
And so we went through and we actually talked because they were interested in adding it to their casinos in Singapore as well.
Oh, well.
And they wanted different data to verify because the humidity is ridiculously high in Singapore. So
Yeah.
they want to make sure it was still just as effective as it would be in Las Vegas or Los Angeles, things like that. And luckily, Singapore is very into UVC as well. And a lot of the government agencies have added UV to their facilities. And so they have actually independently conducted their own studies as well, which can be pulled up online.
Okay.
So if anybody ever questions, like, where these studies come from, I always am more than happy to send over the actual website as well. It's like, hey, go take a look at it.
Yeah.
This is not a document I just took and edited and presented to you.
Yeah.
You can go look at it independently yourself and verify this information. And this really, helps with the convincing of people, because honestly, it is kind of difficult to show somebody an energy they can't see killing something they can't see.
Yeah.
And so documentation becomes key in my sales process in that sense. I want to be able to document and show them visually something that will prove that it's working and getting the job done.
Yeah.
And that's why it makes my job easier like that, just because there is so much empirical data out there from independent sources. Another good source too, not just Google, but if you actually highlight and change it to Google Scholar, it will only pull up scholarly articles. So a lot of those are white papers.
Yeah.
And I don't like using it because it's my company's previous name, but they did a lot of case studies as well for ROI, return on investment.
Yeah.
And so they did a lot of hospitals. One was in McAllen, Texas, or Rio Grande, Texas. They were having problems with indoor air quality. They were actually going to gut their systems and replace them completely.
Ooh.
And we suggested that they put in UV to clean their coils. So they did. And they were rocking 3 chilling towers to make sure that they could get the effects of the air conditioning. After adding the UV, they came back to us a year later and provided their own independent results. And they said they noted about $750,000 worth of savings, whether it would be avoiding hospital-acquired infections. They shut down 2 out of the 3 chillers and only using one of them now to actually chill the water system. So their energy savings,
that's huge,
jumped dramatically with that. And then you factor in all the other things. If they want to, we don't have systems to calculate it, but figuring out how much it would cost for them to pay for a doctor to come in and deal with the hospital-acquired infection, because they have to foot the bill for all that.
Yeah.
The medicine, the bedtime, all those little things can add up and really be calculated into a return investment. And a lot of them love to illustrate it because they were so happy with their purchase that they just volunteered this information. And so we do have a lot of case studies as well. And we don't, bribe them and force them to do it. They just do it on their own accord. Just like, hey, just give us an update. It really helps us be able to promote this to other people.
Yeah.
If you're saying it works and you have your data that we can present to them without our, influence on it, then this really helps us, push a technology that is extremely viable in this particular situation.
I had a quick side thought.
Yeah.
So the reduction of outside air actually might have some more significant relevance to us in the Southwest. Right? We're in a drought. We're getting away with cooling towers. So if we can reduce the amount of ventilation, how that affects our HVAC system, that could have a dramatic effect as we electrify our systems.
Yeah.
As we go from water-cooled chillers to air-cooled chillers.
Yeah.
That could be a significant effect on the cost of energy.
Yeah.
That we hadn't seen before.
Right.
And typically, when income is down for your business, that's when energy is important.
Yeah.
Nobody seems to care about energy while we're making money.
Right.
Casinos specifically.
Yeah.
But when everything is down, then everyone pays attention to how much can we save energy. We start looking at all these different forms. And that's when you had a lot of initiatives taking place throughout MGM and Caesars. There was huge groups created to tackle that.
Yeah.
And their power and influence in financing has dwindled as the economy has recovered.
Sure.
But again, with the energy, how are we going to do that? That might be a way for us to help combat that.
Yeah.
And provide, again, a better, healthy environment.
Sure.
I've also told people too that with the addition of UVC, treating the coil, it actually can earn you LEED credit. So if you're looking to get your building LEED certified to show it's more, decarbonized and more energy efficient, it's actually one of 2 ways. You can either do it for the energy conservation or just providing a safe indoor environment for people. That additional LEED credit was added on after COVID.
Yeah.
So there are 2 different ways you can actually achieve LEED credit with UVC. applications.
All right, guys. Well, appreciate your time. We're going to wrap up here. Is there you get 2 minutes each? If there's anything you wanted to say before we wrap up, Lance.
Just thanks for welcoming me here, and apologize for my absence.
It's
About
okay.
being a
Appreciate
little
it.
late. Yeah, if we can, maybe provide some links and some references so that people can reach out.
Exactly.
And again, outside of us,
Yeah.
Definitely vet through the information. You could reach out to HVAC or mechanical, electrical, plumbing engineers.
Mhm.
Ask them.
Yeah.
A lot of them have vetted through this technology. A lot of them are wary of the technology, and they apply it appropriately.
Yeah.
Have a trusted resource. Ask your friends, and then ask for proof. Go look at the jobs.
Right.
See how they work. Look at the utility bills, and don't believe half of what's out there.
Yeah. Get rid of some of that noise.
Yeah, exactly.
All right, Patrick.
I guess my biggest point I'd like to kind of hammer in outside of what I've covered throughout our conversations here is being proactive as compared to reactive. Don't wait until something is a massive problem before you decide to address it, because that, as we all saw during COVID, caused a lot of problems.
Yeah.
None of us had supplies to be able to get to people in a timely fashion. And so you don't want to be left in the dark. There was a lot of larger even larger facilities, corporate facilities these days, larger office buildings are still taking the appropriate steps now because of how badly they were hurt or impacted negatively by COVID. They don't want that to happen again. So a lot of corporate or larger buildings are still taking the proactive steps to make sure that they're in the right spot. And it's now being called for in engineering specs. It's being spec'd out. We've added ourselves onto a lot of the engineering pages to be able to have it spec'd out in the plans themselves, because it really offers a peace of mind for the customer or the end user that we've added it on. They, at that point, can choose if they want to keep it or not. But engineers are saying, hey, we want to make sure we're recognizing that indoor air quality is a major player now.
Yeah.
I mean, COVID brought it to light, and they're not letting it go, which is great. Just always just keep it in the back of your mind. And like I said, don't trust just the sales guy. Trust yourself and trust the evidence and the paper trail that you can find online or physically in front of you at a library.
Yeah. I think for us FMs, we need to be the good Boy Scout and just be prepared, and if our budgets allow it, and if it doesn't, then we need to come up with a good case to show that upper management that this is something that's viable, it's useful, it's going to be helpful to the public that's on your campus or in your buildings and clinics. So, well, great guys, I appreciate you. Thank you for your time today. It's been great talking about UV lighting and the benefits of it, and we hope to maybe have you back again, Patrick, maybe on a different talk on something else. So thank you again. Appreciate your time, and let Dr. Kowalski know we really did enjoy his knowledge was vast, and some of those things were like right over my head, but it was great to hear. I was like, wow, he's getting done.
Oh, I say that every time he talks. I'm like, man, he's such a brilliant man.
Yeah.
Most of it just goes right over me, but luckily I'm in the field, so I can understand a decent amount of it now.
Right,
but
right.
I know enough to know that he knows exactly what he's talking about when it comes to this stuff, and he's been around it for decades.
Yeah.
So
Great.
No, it's great, and I really appreciate the invite, and I would love to come back and talk to you guys again.
Good. All right. Thank you. Lance, thanks for coming in. We'll see you again for sure. We'll get on some other subjects. So if you out there, FMs, have a subject that you want to hear about, let's send me an email. You can text me. We can have you message me, and let's see what kind of subjects you want to talk about on our next time with FM Insights with Dave Colucci. Thank you.